Hello, let's continue our Sudoku adventure with Oddly Even Keel by Randall. So we have normal 6x6 Sudoku rules, so in each row, each column, and each 2x3 box, we are placing the digits 1 to 6 exactly once each. Because we have lines in the grid, these are sequence lines. So digits increase by the same amount when traveling along the line from one end or the other. So for example, we could do 1, 2, 3. And this is increasing from here by 1 each time. So 1, 2, 3. Or we could increase by 2 each time. 1, 3, 5. Right? Or we can increase by 0 each time and do 1, 1, 1. Now, Sudoku has an issue with that. The line would be okay, but Sudoku says, hey, let's not do that. So other than that, this square is even. You can remember that by it has an even number of sides. And this circle is odd. You can remember that by odd starts with O. All right, and that's it. Those are the rules. There's a link in the description if you'd like to try the puzzle yourself, and I'm going to get started right now. All right, odd is 1, 3. Let's put 1, 3, 5 here, 2, 4, 6 here, and now we're going to forget about those. I don't really like the outline on elements unless I need it, so I'm going to turn that off. I think it looks nicer without, but I know others disagree. Now this obviously can't have a difference of 0. If it had a difference of 1, let's just start from here. We could go the other way too, though. So like 1, 2, 3, 4, 5. So we are increasing by 1. And something I've noticed is, let's color this green. Whatever digit goes here, which actually I'm going to argue can be 1, 2, 5, or 6, but the ends are 1, 2, 5, 6. But whatever this ends up being, 1, 2, 5, or 6, it can't repeat in the column, and it also can't repeat on its own line because we are increasing. And so green actually ends up here, which means green cannot be a 1. Well, actually. Oh, right. So green can't be here also. Okay. I was going to say it could be 1, 1, 1, 1, but that actually makes green not 1. So makes it 1 and not 1. So we know this isn't all 1s at the very least. And so, actually, we know it actually has to increase in one way or the other. Because if it was all the same digit, then this green and this green would have to be the same as well, and it would end up in 2 places in this box. Okay. So all that to say, this can't be 1 or 6 because it's not it's not the beginning of a sequence. So this is either going 1. I mean, with a 2 or a 5 here, this cell here has to be a 1 or a 6. So we're either going 1, 2, 3, 4, or we're going 1, 2. Or we're going 3, 4, 5, 6. That's our only options. Is it? Yeah, because we can't. Oh, wait. From the 5, could we go down to 3? No. I think what I said is right, but I don't know if I justified it properly. So I'm going to think about this again just to make sure. So the difference between these two obviously could be 1. Can the difference be 2? So like, could we go 2, 4? Well, if we did that, this would be 0. So that doesn't work. Or we go 5, 3, but then this would have to be bigger than 6. Yeah. So I think that the location of this does make it so we have to actually do what I wrote before. We're either going 3, 4, 5, 6, or we're going 1, 2, 3, 4. Wait, how did this happen? Well, let me do that again. We're either going 1, 2, 3, 4, or we're going 3, 4, 5, 6. So this is a 3, 4 pair. Yeah, I don't know what I did wrong last time. Good thing I looked at it again. That would have been a wrong pencil mark. Now this cell here goes over here. Now that we know this is 2 or 5, we're either going 2, 3, 4, 5, 6, or 5, 4, 3, 2, 1. So this is a 1, 6. Could be the same as this, but it doesn't have to be. Okay, so this 3, 4 pair, I'm going to color them. I'll make this one blue and this one orange. Because now you can see that these cells see both blue and orange. So these are not 3, 4. These are from 1, 2, 5, 6 only. Sorry. No. Yeah, I did that. I did do that right. Okay. I thought I got that backwards for a second. Where do these come in? So let's go through these. Let's pencil these. So we're either going 2, 3, 4, 5, 6, or we're going 1, 2, 3, 4, 5. So this is the orange 3, 4, and this is the blue 3, 4. So the orange 3, 4 goes here or here. I think it works here. So do we want to color the 1/6s? I'm not sure we know a good way to color them right now. We could color the other 2/5 purple, I suppose, since we're coloring. So the only thing I don't have colors for are the 1 and the 6. I think the even or the odd square might be it might be distinguishing this. I think sequence lines are reversible unless you have something else you can do with them. Yeah, they definitely are. So we gotta get down to these evens or odds at some point to distinguish the 1, 6, 2, 5, 3, 4. That's why the coloring has been handy. I mean, I guess I have to think about this line because I don't know what else to think about. So from 1, we could go. So we could be all 3 odds or all 3 evens, or we could increase by. We could do 1, 2, 3, 2, 3, 4. 5, 4, 3, 6, 5, 4. There's a lot of options here. There's something interesting that I'm thinking about whether this can be the green 2/5. So humor me here. If this was the green 2/5, we'd have to go up. Now, what we couldn't do is we couldn't go up by 1. We couldn't go 2, 3, or 5, 4, right? We couldn't go to the 3, 4 because it would be the same blue 3, 4 because we know we're going the same direction this way and this way, right? And so this would be the blue 3, 4. So we'd have to jump. We'd have to jump to the other 3, 4. We'd have to jump to the orange one. And then we'd jump again to the 1, 6. And it would be the other 1, 6. That does work out. Like if this was 2, 4, 6, this would be 2, 1. So actually this is viable. Darn. So maybe that is what happens. I'm wondering if it can be 1, 6 then. I don't see why not. This is just so many options. I don't know what to do with it. I think it can be any number. Huh. What do I do? Clearly missing something. Okay, I should fill this 1, 6 pair because that means this isn't a 6. I can at least do that. I don't know how much that helps me. I do need orange in this box, and it's in one of these two. Is that helpful? I'm really thinking this ends up... Wait, why did I mark it green? Oh, I marked it green because I was like, if it's green, and I think I left it there. But yeah, it should not be marked green. One of these two is green. We have purple and orange up here. So yeah, we know orange is one of these two, for what it's worth. Orange being here works and that makes it makes it this green because we notice how we're skipping back. I don't know. Where am I? Is there something I'm just missing about this puzzle? It's tempting to pick a direction for one of these, but I mean, it's the same as coloring it. So I don't think that actually helps. It gives you a sense of ordering, though. Like, we know that we always go green, blue, orange. In fact, this tells us an even better ordering. We go green, blue, orange, purple. Then I could call this red. We know that it goes from purple to red. So the only digit not accounted for in this sequence is the one that goes before green, which we'll call yellow. So we know yellow goes before green. So this is our, this is our yellow. Okay. So yeah, thinking about ordering actually gave us that these two are different. That feels important. Yeah, because this 1-6 pair says this can't be the red, because red is 1-6. So this is a 1-6 red. Hopefully that made sense, right? This just gives us the order, the strict ordering of our colors: green, blue, orange, purple, red. And so then the other 1-6 has to be on the other end of the green. And so we're going green, blue, orange this way, so this has to be the yellow. Okay. Now, what does this get us? It gets us that this is the purple 2-5. That's a 2-5 pair, so now this has to be the 4. And so it could be the blue 4, though. It doesn't have to be orange 4. This is a 2-5 pair. I think we're roped. We are roped. So we have the 2-5, 2-5, 2-5. And then this is, oh, so then this is 1-6. That's yellow. And so this has to be orange. And now we know orange is 4. So now we can actually give digits here. This is 4, 3, 2, 1. This is 2, 3, 4, 5, 6. This is 1. That's 6 and 5. There's a 4 on one of these two. And now I don't need the colors because I now know what the digits are. Right, that's not 6. That's not 1. That's not 2. That's not 5. There we go. This is 3, 4. That's not a 5. 3, 4 is restrictive. We have to go either 3, 4, 5 or 4, 3, 2. I think that's our only options. And we can't go 3, 4, 5. This can't be 5. So this is 4, 3. Oops. No, that doesn't work. Oh, we can go 4, 5, 6. Sorry. There's a few other options. Sorry. We can go 4, 5, 6. And I think that does work. So we could go 4. Oh, this can't be a 4 though, can it? Yeah. If this was a 4, this would be a 3 because it wouldn't match the 4. So this would go 3, 4, and then this would be 5, but it can't be. So we can place the 4 here. Gives us a 4 up here, but so this can't go 3, 4, 5, but it could go 3. Oh, it can't go 3, 2, 1 because that's a 2 there. So this can't be 3 at all. This is 4. That's 3. That's 4. That's 1. All right. And so now we can't go 4, 3, 2 because there's a 3 there. So we have to go 4, 5, 6. All right. Perfect. Sorry for messing that up a little bit, but I got there. This isn't 1 or 2, so this is 6. This digit's a 3, it looks like. And then over here we need 5. Down here we need 3 and 6. This digit is a 2. This digit is a 2 as well. We need 3 and 5. And we're done. All right. Yeah, that we had to think about the strict ordering of the colors. And we had a demonstration here of what order they had to go in. That was neat. All right, cool. Well, thanks, Randall. That was a fun puzzle. I hope you enjoyed it as well. If you did, then why not leave a like, subscribe, and a kind comment below.